Hi guys! Today we're on our last new lesson of this chapter. It's been a quick one. Don't forget, our test is next week on everything that we've learned this week. Today we're going to focus particularly on perpendicular lines. As a reminder, perpendicular lines are two lines that cross at a 90-degree angle. Now, we will not be measuring how big the angle is in this class. That's something that you might do next year in geometry. In this class, we'll be focusing on the slopes of the lines. For two lines to be perpendicular, their slopes need to be opposites and reciprocals. Those are two completely separate words. They mean two completely separate things, and both of them need to occur for you to have perpendicular lines. The word opposite means that the signs are different. So one slope should be positive and the other one should be negative. And then the word reciprocal means that they're flipped upside down from each other. Here is an example of two lines that appear to be perpendicular, and then we're going to need to prove that they are. Now, you can't just stare at them and say, that looks like a 90-degree angle, I think we're good. You do need to have algebraic proof that they are definitely perpendicular lines, and we can do that with the slopes. So let's find the slope of each line. To find the slope of a graphed line, you need two dots. And we're going to count the rise and the run. So for this first line, first of all, this line is sloping downward. So I'm going to expect it to have a negative slope since it is starting high and falling down. And if I start at this leftmost dot, I'm going to rise down 3 boxes. So that confirms, that I have a negative slope, right? So down 3 and then right 2 means that my slope is negative 3 over 2. For my second line, I have my 2 dots here. And for this line, hopefully you noticed that it is rising up. Okay, so when it's rising up, that should have a positive slope. That's good because we want them to have opposite signs. And if I count, I like to start at the leftmost dot when I count my slope. If I count my slope, I'm going to rise 2, positive 2, up 2, and I'm going to run to the right 3. So that's a positive 2 and a positive 3. Looking at these two slopes, again, you need to check to make sure two things are happening. If only one of them is happening and the other one is not, then you can't say they're perpendicular. So first we need to check, do they have opposite signs? And the answer is yes, they do. The first one is negative and the second one is positive. And then the second thing you have to check is, are the numbers flipped upside down from each other? And the answer is yes, they are. It's 3 over 2 and 2 over 3. Since they have opposite signs and are reciprocals of each other, I can say for sure, beyond a shadow of a doubt, that they are perpendicular. So this is how you can prove to me that two lines are perpendicular. Now for today's lesson, I'm going to give you a line, and then your job is going to be to graph a line that is definitely perpendicular. Now again, we're not estimating, we're not eyeballing it and saying it looks pretty good. I want you to be algebraically confident that the lines are perpendicular. Just like in our problems yesterday, I'm going to alter the directions from your textbook. And so when you're doing tonight's homework, I do not want you to use the textbook directions. Instead, I want you to use my directions. And my directions are graph a line perpendicular to y equals 2x plus 3, and that passes through negative 3 comma negative 1. So again, for today's homework in your textbook, please ignore the directions and do what we're doing in the video. I like to start these problems by graphing the original line. That way, when I graph the second line, I can, make sure that it looks like what it's supposed to. Remember, though, we're not going off just looks. We need to have an algebra reason why they're perpendicular. When I'm graphing this line, I'm going to start at the positive 3 on the y-axis, which is up here. And then I have my slope, which is a positive 2 over 1. So I'm going to rise up 2 and run to the right 1. And so this is my initial line. And again, our job is to graph a line perpendicular, but it also has to definitely go through this ordered pair. Now, it is important, again, to know what the slope of the original equation was. And so we already graphed it. So hopefully you remember our slope for this problem is positive 2 over positive 1. Next, let's go ahead and start graphing our second line. So I'm going to graph this ordered pair, negative 3, comma, negative 1. And that means go left 3 and down 1. Remember that ordered pairs are the x-coordinate first and the y-coordinate second. It's different than your slope, which is the y change on top and the x change on the bottom. Now, everything we've done so far has been exactly the same as yesterday's lesson with parallel lines. And so our last step is where we're going to have to do something different today. And so for our last step, we're not going to just use the slope that was given to us in our original equation because we want perpendicular lines. So for perpendicular lines, I'm going to find the opposite and reciprocal slope of the original slope given to me. So if my original slope is positive, my new slope will be negative. And if my original slope was 2 over 1, my new slope will be 1 over 2. And so the slope that I want to use for my perpendicular line is negative 1 over 2. Starting at the point that we've already graphed, I'm going to rise negative 1, so I'm going to go down 1. And then don't forget on negative slopes that the bottom number is still going to be a positive number. So the top number was negative, but the bottom is a positive. So we're going down 1 box, but we're going to go right 2 boxes. And it should be pretty obvious if you're going in the wrong direction on these problems because the lines won't be perpendicular. So, make sure that your lines actually do look perpendicular. For this line, I am going to graph 3 dots because I want it to be as accurate as possible. And here I have my perpendicular line. Now, again, we did not just eyeball it and say, that looks pretty good. I did actually calculate the slope and I made sure that it was going in the correct direction. Let's do one more just so we're confident. Again, I'm going to alter the directions to say graph a line that is perpendicular. So that's what I'd like you to do on your homework tonight. That's also what Delta Math wants you to do, right? They want you to graph a line and then also to state your 2 slopes. So just like we're doing in the notes right now, right? You're going to state your original slope and you're going to state your new perpendicular slope. All right. So I need to graph a line that is perpendicular to this line. So let's go ahead and graph that line right now so that we know what it looks like. This line starts at negative 3 on the y-axis. So I'm going to go down 1, 2, 3 to right here. And this slope is negative 2 over 5. So starting at this dot, I'm going to rise negative 2, which means I'm going to go down 2. But then I'm going to run positive 5. So remember that even negative slopes run to the right. Positive slopes go up and right, negative slopes go down and right. So that right component is still there. So here's my original line. And again, the slope of my original line was negative 2 over 5. Now I'm going to start graphing my second line. My second line starts at negative 5 comma 7. That's negative 5 on the x-axis, and then positive 7. And then here's the part where it's really important that you remember and that you read the directions carefully, right? So if I read the directions carefully, I want perpendicular, which means I need to change my slope. I need the opposite sign. So in this one, my original is negative, so I'm going to make my new one positive. And I need to flip it upside down. So 2 over 5 will turn into 5 over 2. So again, opposite signs. If this one's negative, that new one should be positive, and then flipped upside down. So my new slope is 5 over 2. Positive 5 over 2. Now you'll notice that my graph is not big enough for me to count up 5 and right 2. That goes way off the graph. I'm not even confident that's in the right spot. This is why we talked about earlier this week that every slope can be written using two different forms. So I have my slope of positive 5 over 2, but I can also, for graphing purposes, rewrite that as negative 5 over negative 2. And what that allows me to do is instead of rising up and right, I can rise down and run to the left. And that allows me to stay on the graph that I was given. And I'm still graphing a positive slope, right? If you can see that the line is still sloping upwards, okay? And I know you can't tell because they're not actually connecting, but if I extended out my red line, my initial line, and made it actually connect with the green line, these would be perpendicular. All right, so again, this is what I want your homework to look like. I should see graphs, I should see slopes. This is what your Delta Math wants you to do as well, right? They want you to graph the line, and then if you scroll down to the bottom, it's gonna ask you to state the slopes, the original slope and the new slope. So make sure that you're completing all of that work, and I will see you today.